Today, we're solving inequalities, stuff we've definitely done before. We're going to kind of set us up on the old front side, and then the back side, we'll learn something new about the inequalities, but just going to refresh the old memory. Remember, the old inequalities are the less thans, or the greater thans, or the less than or equal to's, or the greater than or equal to stuff. So what is this symbol right here? Is that a less than or equal to, or is that a greater than or equal to? That's a less than. They want us to solve for A and figure that out. So let's clean this up. Let's distribute to 7. You can punch stuff in also if need be. Remember, sometimes this symbol has to switch when we're solving. It'll switch if you multiply or divide both sides by a negative. So we have to switch that guy around. So I have distributed the 7 through. Next move is to add 63 to both sides. That does not change the sign at all. If you add 63, so it's still a less than or equal to. And that would be a 7. Is that 147? Is that right? Yes, no, maybe. Is that right? And then obviously our move is to divide by 49. Does the symbol switch if I divide by a positive 49? Nope. And I'm going to bet that that is 3. Is that right? Cool. So every A value less than or equal to 3 is going to satisfy this inequality. We will graph all of those solutions on the number line down here. Since there's only one inequality, we don't need any helper graphs. I'm kind of setting this up for next time's lesson. So we just go straight to the number line. Got to put a dot on 3. Is it an open dot or a closed dot since that's an equal to bar? Closed dot. And less than, these are all the numbers, less than it. So please put it on the number line and make it nice and fat, like I am, like if that was a pencil. You may have had a math teacher show you to put that stuff above the number line. I don't like to do it that way because of what we have to do next time with the compound inequality. So let's put it on the number line. These are our solutions. But then it's the old notations that get a lot of people. They are going to ask us to write about our solutions in set notation, and we'll learn about interval notation on the back side. But set notation is weird. That's a crazy math symbol. So we'll put the set bracket. And it's the set of all, whatever variable you're using. So in this case, we're using the letter A. Set of all A's such that. We put this up and downer guy. It's said out loud as such that. The set of all A's such that. And then whatever we got up here, that goes next. A is less than or equal to 3. Then you close the set. Because what that means is they were like, yo, bro, what kind of values could I put in for A to make this a true statement? And this says, well, out of all the A's in the world, in the set of all A's, the A's that work are the A's that you pick that are less than or equal to 3. So the set of all A's such that A is less than or equal to 3. Let's roll with that again. Let's distribute here. Just watch, sometimes that symbol has to switch. Please cross your Z's. And then you got choices of where to move the variable. I'm going to ask you a simple question. Which one of these, top one or bottom one, do you feel more comfortable reading? The top one or the bottom one? I think the top one makes sense to us. But they both say x is greater than 2. Both of those say the exact same thing because you have to read from the variable. But it makes more sense if the variable is on the left side because we read from left to right here in English. So why don't we move the variables to the left side of the symbol in that case, because that's how we like to read it. So I'll take the 27 and take away 35. And I got negative 8z. Is that okay with y'all? Plus 12. Symbol does not switch because all I did was subtract. Still subtracting 12 from both sides. And I got negative 18. Is that right? And then we will divide both sides by negative 8. Since we are dividing by a negative, that's where this symbol has to switch. He is a greater than. He's going to turn into a less than. And you'll get 18/8, which is really 9/4. If you reduce that, if you want me to show you how to reduce that on your calculator again, you just do like 18 divided by 8, and you get this, and then you hit math, enter, enter. So math, enter, enter. But it's nice to see that decimal is like 2.25-ish, so I know where to go put that guy on my number line. Since he doesn't have a place, we're going to have to put our dot, which is what? Open or close? What's our dot? Open dot. But we got to go put a 9/4 right there. It's like it's at 9/4 because you just can't tell where it's at. So somewhere in between the 2 and the 3, like at 2.25, you know, it's like just tell me that it's 9/4. And less than means we're going to the left, to the left, to the left, to the left. Fatty boom batty on the number line. Open dot because that point doesn't actually make this solution true in that case. It's not included. And it's the set of all z's such that, go throw your answer in there. Just a little refresher. Questions about that? Cool. Number 3 messes a lot of people up because they see the fraction. Let's just deal with it. How can I get rid of this stupid divide by 3? Multiply both sides by 3. Will the symbol switch if I multiply both sides by 3? Has to be a negative number that you're multiplying by. So that'll be a 3c greater than or equal to the c plus 4. The c plus 4, people are like, well, don't you have to take all that times 3? Sorry, my pen's frozen. I did take everything times 3, and 3 times the c is 3c, and 3 times this whole fraction, since it has a divide by 3 with it, the times 3 and the divide by 3 cancel each other out. So solve that for c, graph it, and put it in set notation. You can pause the video to get that done. So I solved her down to get c greater than or equal to 2. Go to the number line, close dot because of the equal to bar, greater than. These are where all the numbers are greater than 2. And it's the set of all c's such that c is greater than or equal to 2. One more of those. If you would, you can work together, or if you're at home, you can find a little brother or a little sister, maybe a cat or a dog, something, goldfish, if they want to help you. Get this done. Please pause the video. So I distributed, and then I moved the 6r over to the left side, and I had to switch the symbol at the very last spot when I divided both sides by a -5. So then I got all the r's greater than 5, set of all r's such that r is greater than 5. That's just old school, getting us familiar with the set notation. And then we get some story problems. I'm big on story problems. Tell you what, we're going to do these out of order because number 5 is harder than number 6. Let's start with the easy one, right, number 6, and then we'll come back to number 5. So we're on 6. Larry. Larry is hauling bags of rock for his landscaping project. Each bag weighs 45 pounds, and the cart he is using weighs 85 pounds. So here's Larry. He's got a, you're going to see like thousands of these problems, very similar to this. So please ask a question if you have it. But Larry's got like a pickup truck. You know, he's going to put all these different bags of rock in there. But he's also got one cart to like when he unloads them from his truck, he's going to put them all in the cart and then roll it to where he needs to go. Does that kind of make sense? So he's got a cart on the truck, and he's got all kinds of bags of rock. Each bag weighs 45 pounds, but the cart weighs 85 pounds. His truck can handle a 2,000-pound load. So let's set up an inequality to find the number of bags he can carry with his cart on each load and then solve. So here's what we got to do. And yes, I'm serious about it. The very first thing we do is define our variable. Any story problem will define a variable. We usually like to use the letter x, but we will define it to be what they are asking us to find. So I will let you and your neighbor read through here and see what are they asking us to find real quick. We have decided that they want us to find the number of bags of rock, right? So that's why we're going to say x is the number of bags. That's worth points right there. Then we'll write an inequality. Cool. So let's talk about like which one of these varies and which one of these stays constant. He has to have the cart on his truck, right? How many carts does he have? Just one. And it weighs 85 pounds. That will never vary, right? You know, the cart's always going to weigh 85 pounds. But couldn't the number of bags of rock that he puts on his truck vary? Couldn't he put like 1 bag, 2 bags, 10 bags, 100 bags, whatever? Couldn't that vary? So that's why next to the 45 pounds, we're going to say it's 45 pounds for every bag of rock that he gets. How many bags of rocks did he get? Well, that's X, right? X is the number of bags, and he's going to, they each weigh 45 pounds apiece. But what else is on his truck is the cart. So we got to add to it the weight of the cart, which is how much? 85 pounds. And his truck can handle 2,000 pounds. So I left a space here for a symbol, but his truck can handle a 2,000-pound load when you put it in the back. We don't want an equal sign because it doesn't have to hold exactly 2,000 pounds. We have to decide, could it hold more than that or less than that? What do you think? It would have to be less than the 2,000 for sure, because if you do more, the truck's not going to handle it. And somebody also said, or equal to, because can't it totally handle the 2,000-pound load? So here's what he's putting in the back. Bags, 45 pounds apiece, plus the cart, 80 pounds. That's got to be less than or equal to 2,000 pounds. Sound good? Then all we got to do is solve for x. So I'll let you solve for x. Subtract 85 from both sides. $2,000 take away 85. 1915. And then we will divide. Does the symbol switch when I divide by 45? And I get 42.5, blah, 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 repeating. Changing this to a fraction by doing math, enter, enter, doesn't make any sense in this situation, because this is a story problem. I'm not going to say, well, he can hold less than or equal to 383/9 bags of rock, you know. I think the decimal makes more sense, so let's put the decimal and just round it to the nearest tenth. I'm going to say x has to be less than or equal to 42.6. But if you go to a hardware store and buy the bags of rock, they're not going to sell you the 0.6 bags of rock. They have to sell you in whole number integer amount increments, right? So how many bags of rock, if the bags of rock have to be less than or equal to 42.6, could he get 43 of them on there or 42 of them on there? Less than, right? Less than this. So we will answer in a sentence, Larry, or he, whatever you want to say, Larry can hold, let's say haul. Larry can haul at most 42 bags. Larry can haul at most 42 bags. He doesn't have to buy 42 bags, but that's the limit that his truck is going to have right there. You'll see a problem like that show up often, about hauling bags of rock and having the nice cart. Why don't you read number 5 real quick? I'll pause. You read. So Jim is making this much per hour, and I think we're all intelligent enough to know if you get paid $5.75 an hour, you don't get to keep it all, right? Don't think I take taxes out of your paycheck. Once you make over a certain amount, which I think is just $600, you know, once you make more than $600 total in a year's time, they start taking taxes out. But if you don't even make $600 in a year's time, they say don't worry about it. How many hours does Jim have to work if he wants his take-home pay to be at least $110 per week? So let's define x first. We're going to let a variable be, and let's go back to the question and see what they're asking us. What do you think that they're really trying to ask us? How many, what? Hours. So that's exactly what we'll do. We'll do x is the number of hours worked. And there's 2 ways to set this up. But what makes it challenging is that he's not just getting paid $5.75 per hour. They got to take some money away. So I'll do it the long way the first time, and I'll do it the short way the second time. See which way you like better. You know, it's your choice. But here it is. Jim's getting paid $5.75 per hour, and X stands for the number of hours. How could I just write that down? $5.75 per hour. Multiply them, right? $5.75 per hour, right? But he's not getting all of that money. So we have to take some of it away. We have to subtract away 26%. So 0.26 is 26% of his total pay. Well, his total pay is $5.75 per hour. Would you agree that that is true? He is getting paid $5.75 per hour, but we got to figure out what 26% of that is. And then they want that to be at least $110 per week. Well, at least means he could have greater than or equal to 110 bucks. Because if you made at least 110 bucks, that's the smallest amount you could have. Right? You could make 150 bucks, 200 bucks, and that's all good. But if the least amount you made was 110, it's greater than or equal to. So what we got to do is do a little multiplying of the 0.26 times 575. Thank you, calculator. I realize that's 149.5. Don't round it off, because the government sure isn't going to. What was it? 149.5. X greater than or equal to 110. I will let you finish solving this. You can pause the video, give it a try. So I multiplied this out, combine these like terms, and now I'm ready to divide. I got to do 110 divided by that. If you've never seen the previous answer button in your calculator, I'll show you where that's at, so you don't have to keep retyping these numbers in if my pen would wake up. So I want to do 110 divided by this number, but I sure as hell don't want to retype it in all the time. Right above the negative symbol is an ANS, which stands for previous answer, so you have to hit second to get to it, and second previous answer. And I got about 25.85. Let's talk about that. First, changing it to a fraction. If I math enter that, does that make any sense for this story problem? Those fractions don't really make sense in this story problem. So I like the decimals. Let's see what X stood for again. X is the number of hours worked. Most of us have had a job in here, you know. It's like, do you have to work in whole number amounts? Like if you show up at 4 o'clock and we're supposed to get off at 8 o'clock, you know, do they make you stay till 8 p.m. on the dot every single time, or is it okay if you work decimally or fractionally parts of an hour? What do you think? Are decimals okay? You can definitely do that, right? You know, you just clock in and clock out, right? You know, and they add up all your minutes and hours and stuff at the end. So you can totally have a decimal amount. So X has to be greater than or equal to, let's just round it to the nearest tenth, is what I usually round to if they don't tell us. So 25.9 hours. Is it 25.9? Was that what it was? Or 28? 25, thank you. 25.9 hours. This means that old Jim here has to work what kind of hours? More or less than 25.9 hours? Yeah, so we'll answer it that way. Jim has to work at least 25.9 hours for the minimum of the $110 per week. We'll just kind of just shorten the sentence up. So like Jim has to work at least or a minimum of, however you want to say it, right? Has to work. To work at least 25.9 hours. And if you were figuring that up for yourself, or if Jim was, he's like, okay, I basically got to go work 26 hours this week. You know, it's like it's pretty stinking close to 26 hours. But he could actually get the 110 bucks by almost working 26 hours that week. Any questions about that? Story problems. Define variable, do the algebra, write the answer in a sentence. That's what I'm looking for. Cool. All right, that's all stuff we have done before. Let's go to the back side. Interval notation. For most of us, this will be a brand new thing. Some of you have seen this before, right? So it's a good refresher. But interval notation is the way mathematicians like to write things if we get the opportunity. Not every answer can be written in interval notation. So it's kind of back to the front side. You know where we solved for our variable and we had it in set notation? They're going to have us put it in interval notation. So first things first. Part A, set notation. Part B, interval notation. Let's do part A on number 7 right away. Here's a graph in blue right here Tell me, without doing the crazy set notation, let's just say x. What is this a graph of? X is, should I have a greater than or a less than sign? What do you think? Less than. Equal to bar? What do you think? Nope. 2. You cool with that? But to put it in the true set notation, we'll do the set of all x's such that. So it's just like reading the graph. But the interval notation is easier to understand once we get a hang of it, right? It's just kind of like texting language. It's easier to understand once you know it. Once you know what LOL stands for and all this stuff, it's like, oh, it's just easier to type that kind of stuff. So interval notation. Here's what I got on the number line. Just follow my pen. If I started counting 2, 3, 4, 5, this arrow means that we're going to where? 6, 7, 8, 9. Where would it stop? It doesn't stop. So we say that that goes to positive infinity. That's going to go on forever and ever and ever, which is called infinity. But what if I went the other direction, -1, -2, -3, -4, -5? Doesn't that go on forever and ever and ever? But it sure doesn't go to positive infinity. It goes to a place called negative infinity in that case. Does that kind of make sense? You got a positive infinity as we go to the right, and you got a negative infinity as we go to the left. It's just a way to say which way we're going, which direction, but it's going on forever and ever and ever. So here's how I tell what the interval is. I use the straight edge test. You could use your hand, you could use a straight edge, you could use your pencil, whatever. But I put this straight edge going straight up and down, and I'm looking at the blue graph only. And I ask myself, this blue graph, if I start as far left as humanly possible, like I could start it right here, like if you're looking at the right-hand edge of this guy, you know, if I start it right here, you know, it's like, couldn't I just move it as far left as possible? And how far left could I go? To negative infinity is how far left I could go. Would this arrow run into my straight edge if I was over at negative infinity? What do you think? Does it run into it? You don't think so? Why not? Yes, they keep going. Would the arrow run into the straight edge if I set it on negative infinity? Like it's there. It's on negative infinity. Would the arrow run into it? Yes or no? We have decided that yes, the arrow does run into the straight edge over there at negative infinity. That's where we're going to start our interval from, negative infinity. So the infinity sign, I have a hard time making it. It's like a sideways 8, but I have a hard time making it, so I just usually put like 2 circles right next to each other touching. But it's negative infinity. And you know like how we have open dots and closed dots with our system in this? Interval notation doesn't use open dots and closed dots. They use parentheses and they use square brackets. The parentheses, maybe if we make a little note at the top of our paper, the parentheses are like open dots, and the square brackets are like the closed dots. Sorry. The square brackets are like the closed dots. And the weirdest thing about negative infinity is just what you were thinking. It's like, how could you get there? You can never touch it, you know? Infinity or negative infinity is like MC Hammer, can't touch it. You know, there's no way you could get there. So that's why it's like an open dot. It's never, ever included. So negative infinities or positive infinities, always get a parentheses with them. Then let's move the straight edge over to the right. If I move it to the right, is the blue thing still touching my straight edge? What do you think? Still touching? Yes, no, maybe? Yes, still touching? Still touching? And we're only looking at the right-hand edge. Once I get to 2, would you believe that that's where something weird starts happening, right? So that interval is going to stop at 2. And does 2 count or not count in that situation? Included or not included? Not included. That's an open dot. Open dots get parentheses, so we're going to close up the old parentheses. And if you kept going, only looking at the right-hand edge of my straight edge, it's not touching anymore. Let me use a thinner straight edge for you guys in person. So that's weird. Let's try some more and see how comfortable we get. First, let's just put this in set notation. Let's roll with x, and we know that the arrow's going to the right, correct? So what symbol do you want? Greater than or less than? Greater than or less than? Greater than. -2. Should we put an equal to bar with this guy? Yes. And we'll do this set of all x's such that. But when we start our interval, I'm going to put the straight edge way over here at negative infinity. Is the blue arrow running into it at all over here at negative infinity? It's not. Not touching it, not touching it, not touching it, not touching it. Boom! Doesn't the straight edge start touching the blue arrow right there? Where did we start from? At negative 2. Is negative 2 count or not count in this situation? It counts. So that is like a square bracket. So because he's included, we don't put a parenthesis, we put the square bracket. Then, as we keep on keeping on, let me turn this again. Would you believe that that straight edge just kept on touching it? Sorry. As we went to the right, it's going to keep touching, keep touching. How far would that thing go? All the way to positive infinity, which we usually just say it out loud as infinity. Always putting a parenthesis with infinities, though. Can't touch infinity. Always putting a parenthesis. So this graph right here goes from negative 2 included to infinity. In that case, not included. Interesting. Let's try again. Ooh, 2 different boundaries. So in set notation, focus, let me just highlight, focus on this dude right here. Could we write an inequality for the orange guy? Call an x, and how in the world does x relate to the negative 1? Less than or greater than, first off? Less than? Any equal to bar? Nope. But because there's a second dude, we're going to throw an or in the middle. And we'll write the other inequality. That's x greater than 1. If I was throwing darts and I had to land on the blue parts, like if I was to erase the orange now, it could land on the blue one that's at x is less than negative 1, or it could land on x greater than 1. That's where those solutions are at. I got choices there. So it's the set of all x's such that, boom. And all of that stuff goes in there. But let's go with the interval. The interval, if I start way over here at negative infinity, I don't care which blue arrow, it's just got to be one of them. Would the blue arrow run into the straight edge? Yes. So we're going to start from negative infinity with our interval. And it always gets a parenthesis. You can't include infinities because you can't get there. And I'm going to work my way to the right, and to the right, and to the right, until I get to a weird place. Would you believe something weird is going on at 1 on the number line? So that first interval went from negative infinity to negative 1. I said 1, but I should have said negative 1. Let's talk about if he's included or not included. Since that's an open dot, would you believe he's not included? Is that a parenthesis or a bracket? Parenthesis. Not included. But then I keep going, and there's this gap in between here, right? So we bridge the gap with an old familiar friend, the union symbol. Looks like the letter U, but it doesn't have that staff on it. Like this is the letter U. It has a little staff, just like a union symbol. So I got to unite it with, where do we start from? It starts at 1. But it's not actually starting at 1, because 1 is not count. It's not included. So that's why at 1 gets a parenthesis. And then would you believe that that interval keeps on keeping on all the way to positive infinity in that case? So, and infinities always, always, always get a parenthesis. Weird. That's called interval notation. Number 10, that's interesting. How many blue pieces do you see to the graph? Over here there was 2. Here was 1. Here was 2. Right? How many blue pieces do you see right here? Just 1. But doesn't it have 2 boundaries? Right? You know, it's got a left boundary and a right boundary. So if we go in in set notation, that's where we need a compound inequality where x is in the middle and the symbols point to the left both sides. Who is the leftmost boundary on this guy? Negative 5? Negative 5 goes on the left side. Should it have an equal to bar with it since there's a closed dot right there? What do you think? Equal to bar? Yes. Right boundary? 5. Should it have an equal to bar? Yes. So the weirdos, the segments, basically, that's a segment. You know, it's not rays or anything like that. That's a segment in there. So let's have two boundaries. That's how we write it. Set of all x's such that x is greater than or equal to -5 and x is less than or equal to 5. See if you can put that in interval notation with your neighbor. Give it a try. We'll check it out. 3/4. If I put my straight edge way over here at -infinity, does the blue thing run into it at all? Does not go to -infinity. Where does the blue thing start from? -5. And since it was a closed dot, should I put a bracket or a parenthesis with that? Bracket. Now watch this bracket. That's the wrong bracket. You see, it's like you got it backwards. You want to do the bracket that, like if you were typing, you need to put this bracket. Cool. Then moving to the right, touching the blue, touching. Where does it stop touching at? At 5. And that is also included. And then if you keep on going to the right, there's nothing anymore over there, right? It does not keep going. Notice this. Here's the easy way to realize how many intervals you need. How many pieces was here? 1 or 2? How many pieces? 1 piece, 1 interval. This had 2 pieces, 2 intervals in that case, right? Because you had to spread the gap with a union. Why don't you and your neighbor try I guess that's all of them. They want us to now graph this, which is already in set notation, and put it in interval notation. So let's first graph it. This is say instead of all a such that a is less than or equal to 3, we need 3 on the number line somewhere. That's a critical point to us. I usually just put it in the middle. And then you got to put a scale. I don't care if we go every one or if we skip. So I'm going to go 4, and I'm going to put a 2 and a 1. We need to at least fill out every other tick mark on the scale. And if we graph this guy, what kind of dot is going on 3? Open or closed? Closed dot. And since it's less than, would you believe that this is my arrow? Yes, no, maybe? Yes. Let's talk about the interval. The answer that they want is in interval notation. First, let's see how many intervals. How many pieces to the graph do you see? 1 piece or 2 pieces? 1 piece. Is there an arrowhead on that piece? Is there an arrowhead? That means infinity is going to be involved. It might be positive infinity. It might be negative infinity. But since there's an arrowhead, that means it's going to infinity. So read from left to right. As far left as I go is way over here. Isn't that thing going to go on to negative infinity in that case? So negative infinity always has a parenthesis, and it's going to keep on going. Because we read from left to right, we stop at 3. Doesn't it stop at 3? And it is included. Questions about that? Please graph number 12 and then put it in interval notation. So remember to put your scale on there. And that was greater than or equal to 0. So 0 counts. He's included is where you'd start that guy, and it goes on forever and ever and ever. 1 ray, 1 interval. There was an arrowhead, so an infinity was involved somewhere. Okay. This guy, mess. He's an and statement. This is going to make a segment because isn't the t in between 2 numbers? Like it's between a 1 and a 3. So those are our critical values, the 1 and the 3. I'm going to put the 1 on the left and then just start counting up until I get to 3. Tell me, what kind of dot should I put with the 1? You have to read like this little symbol. Is it open dot or is it a closed dot? Open dot. And the same thing with the 3. The 3 has an open dot because you're reading this symbol. And this is all the stuff in between it. To read this in English, it says it's all the t's such that t is bigger than 1 and at the same time less than 3. So like everything in this green region, that variable, that number that I'm picking, like if I pick this blue dude, boom. Would you believe that that guy right there is bigger than 1? And that guy is less than 3 at the same time? It's like every number in here is bigger than 1 and less than 3 at the same time. So to write it in interval notation, I still only see one thing. It's just one segment. But it doesn't have any arrowheads, so there shouldn't be any infinities involved with it. Reading from left to right, the farthest left this thing goes is 1, and the farthest right this thing goes is 3. What do you think about this answer, though? Is this the good answer or the bad answer in that case? Why? Yep. Correct. We need this. How about this in purple? This is the right answer in blue. How about this in purple? Would that work? 3 to 1. Doesn't work because you're going backwards. We don't read from right to left. We read from left to right. So, no purple. Try this one. Guess how many pieces you need since there's an or statement. Guess how many pieces? 2 pieces. And we probably better count by something to where we can go from 2 to 14 with our tick marks on there. You can't just put a 2 and put a 14. You have to have a scale. So I'm going to put a 2 way over yonder and probably count by 2s. Finish it off since I was going every one. And then x is less, excuse me, so y is less than 2. Bada boom. Fat boy. Y is greater than or equal to 14. You know, one of the dots could be open, one of the dots could be closed. It doesn't matter, right? You just got to do what they tell you to do. You'll see a lot of multiple choice ACT questions like this. Just simple stuff, seeing if you know what the interval is for these guys. And since you got 2 rays, 2 different pieces, you need 2 different intervals. As far left as it goes is negative infinity. Always put in parentheses. It goes up to 2. Not included. And then the other one, it starts at 14. It is included, so that's a bracket, and it goes to infinity. But don't forget you need that weird symbol in the middle, which is a union symbol. Throw the union in there. 2 more. Get them both done. But the thing you got to do is if one of your numbers, one of the critical values, isn't on the scale, you have to put it. So like here's -3. I could put an open dot there, but nobody knows if that's actually at -3. It's like, how do I know it's not at -2.9 or something like that? So put -3 right below it, so that way you're telling people that's where it's at. 8 is closed, and since it's not an or statement, it's the dudes in between. And in an interval, it's from left to right, from -3, not included, to 8, included. And then please help me. What does this mean again? All the real numbers. I got to graph all the real numbers on 16. So people always ask a great question. Well, where should you start on your number line? If you got to graph them all. It doesn't matter. Every number in the world is going to get graphed. So I usually throw a 0, a 1, a -1, a -2. I just start there. And I got to graph every stinking real number. Every real number. So that's all of them. So would you believe that I'd start putting dots, and the dots would get so close together that they just like fill up the whole number line? Isn't everything on the number line a real number? So the question is, do I need arrowheads on it? So no arrowheads? Or does it keep going? Could it keep going? So I need arrowheads to go all the way to the right and all the way to the left. And if I start my interval way over here at -infinity, because that's where this thing goes, you cool with it going from -infinity? And then if I move to the right, it's still touching the blue thing, it's still touching the blue thing, it's still touching, still touching, still touching. Bro, that thing touched everywhere. So it went from -infinity to where? To positive infinity. And let me ask you this. If I asked you where all the real numbers were, would you believe that it goes from -infinity to positive infinity and everything in between that, right? That's all real numbers. That's how we say all reals is from -infinity to positive infinity. Let me know if you have any questions on that, and have a good